Welcome back. The next page of notes is talking about determining whether or not two events are independent. Um, this will make more sense after we kind of talk about the difference between independent and dependent. So I'm going to come down here and we're going to look at this. Sometimes all you have to do is read the problem, and it will be extremely obvious whether or not two events are either independent or dependent. Um, and then if it's not real obvious, then we can maybe use the mathematics to help us figure it out. So um, the problem that we did earlier, where we selected a king from a standard deck of cards, we did not replace it, and then we tried to select a queen from the deck. Well, we saw that finding the probability of drawing a queen, given that the king had already been picked, we saw that it changed my sample space to 51 because we did not replace that first card. And so when we compare the probability of finding or drawing a queen, given that it's a second card, that's not the same thing as just drawing a queen the first time. That would be 4 out of 52. So drawing that king, this thing right here, changed this outcome, because without drawing that king, my probability of drawing a queen is 4 out of 52. But because I took the king out of the deck of cards, my sample space changed, and now I got a different answer. So this outcome was affected by this thing happening. So that means that these two events are dependent. Okay, again, these two events are dependent because drawing the king changed the outcome of just drawing a queen. And you can see it mathematically right here. This one's not easy to see mathematically, but you don't really need to. What does, so it says we are going to toss a coin and it's going to land on heads, and they've labeled that event A. So A is defined to be landing on heads. That's event A, and that's how we would label it. Okay. Um, so and then we're going to roll a six-sided die and obtain a six. Okay, so event B is that we roll a die and we get a six. Okay, so that's the two things in the sample space. And so what they want us to find is the probability of the second thing given that the first thing has happened. All right. Well, what does tossing this coin affect the rolling of that die? Absolutely nothing. So the tossing of this coin, the tossing of the coin has no effect on the die that we're going to roll. So since there's no effect, the probability that we get a six, there's 1/6. That's the only thing that we're interested in. So that's one outcome out of a total. Now, for rolling a die, remember the sample space would be 1, 2, 3, 4, 5, 6. So there's the sample space. So there's 1, 2, 3, 4, 5, 6 outcomes in the sample space. And event B is only interested in us getting a 6. So one outcome out of a possibility of 6. This event A right here, flipping that coin, had no bearing whatsoever on the die. So these two events would be independent. And like I said, it's really more common sense than it is anything else. But we'll see that if all we did was roll the die, we didn't flip the coin at all, it would still be 1 out of 6. Because again, this heads over here happening had nothing whatsoever to do with what happened with my die. Tossing a coin and getting a head, and then tossing a coin again and getting a tail. Well, you might be thinking, hey, that's well, we're tossing coins now. It doesn't matter. A is being defined to be landing on heads. and B is being defined again to land on heads. But you guys, once we flip a coin, it doesn't matter what the outcome is. We flip that coin again, we still have a 50-50 chance. The sample space is still going to be heads or tails. Okay, so the probability of getting B, given that A has already happened, doesn't change anything, because even though we're flipping the same coin, what happens on the second toss of the coin has absolutely positively no effect on what happened the first time. That first flip had no effect on the coin. It doesn't change the coin. It didn't increase or decrease my chances of that second toss. They're completely independent. So the probability of landing on heads, given that the first time I already landed on heads, the probability is still one outcome out of a total of two possibilities. So these are also independent. And the mathematical way you could check that is say, well, what's the probability that B happens all by itself? Well, that's still 1/2. So those are independent events. I'm going to stop this video before we go to the next page because I'm afraid that they're too long. But here we'll look at some mathematical ways that we can do it if we don't know enough about our events to determine just based on kind of, our common sense or the reading, the contextual situation.